Alright, continuing the Hasselbach equation legacy, we're going to be using this equation to solve an even harder question. Okay, so a buffer solution with a pH of 5, so we can go ahead and say the pH, and it would help to just write down the information, like dissect it piece by piece. Okay, contains both acetate acid and its conjugate base, where the total concentration is 0.200 for both the acid and the base. So the solution to get a pH of 5, contains both of these. So, and the total concentration is this. So we can go ahead and say the concentration of the acid plus the concentration of its conjugate base is equal to 0.2 m. Alright? Given that the K of A is 1.8 times 10 to the negative fifth, well, we have K of A, and we need pK of A for the equation. So, pK of A, K of A is equal to negative log, in case you didn't know, well, you should know by now, K of A, so that equals to negative log, and let's plug it in with a different color, of 1.8 times 10 to the negative fifth. And if you remember from the last video that the NH3 had the same exact K of B value and got us K of A. So I don't even need to get out a calculator for this, since I just happen to know this by memory. It actually equals 5.56 times 10 to the negative 10. I also realized in the last video I said K of W was equal to 1 times 10 to the negative fourth. Well, I meant 14th. Like, throughout my calculations, it said 10 to the negative 14th, but I wrote down fourth and said it once and never really noticed that. But anyway, I make mistakes. We're all humans. Okay, so 5.56 times 10 to the negative 10th. We get that by just taking this and dividing it by this, because remember, K of W equals K of A times K of B, and then we're solving for K of A, so K of A is, or not, we're solving for K of A, so it's K of W divided by K of B. Oh wait, what am I doing? I was going ahead of myself. Yeah, this is for the conjugate base. I should probably get out the calculator for this. 1.8 times 10 to the, no, 10 to the fifth, and then negative log of that. 4.74. 4.74. Sorry about that. I was getting ahead of myself. Like I said, I'm just human. I make mistakes. So now we can just plug it into this equation. But well, first, let's finish reading the rest of this. What is the concentration of both the acid and its conjugate base in solution? So basically, we need to figure out what both of these are. But how do we do that? We need to figure out what the ratio is. Okay. It wouldn't help to just tell you how to do these. It's best if you know what the heck is going on here while we're doing this. So 5.00 is equal to 4.74 plus the log of the acid. I really hate writing the, no, not the acid, of the base divided by the concentration of the acid. Okay, and that's supposed to be a parenthesis. Okay, subtract from both sides. We get, what is it? Gosh, minus 5. We get 0.255. So 0.255 equals the log of both of these. not acid, base. The base divided by acid. We do 10 to both sides. So we do 10. Because remember, we subtracted this. This is this. This is a positive number. 10 to the point 255 is equal to the concentrations of the base over the acid. Basically, what we're solving for is the ratio, right? And the ratio is 10 raised to the point 255, be more exact, 1.7, let's say 1.8. It's equal to 1.8. So that would mean that the concentration of the base is 1.8 times the concentration of the acid at that point, right? So yeah, that's what it is. Now, how are we going to figure out what their concentration is? Like, we know both of them added together is this. And the ratio between the base and the acid is 1.8. Like, the base is 1.8 times the concentration of the acid. So how do we figure this out? Well, what we need to do is figure out the fraction of one of these of the total, I should say. So let's go ahead and assume that the base is 1.8 m and the acid is 1. Like, it doesn't matter what it is, just as long as it's ratio. So we're going to go ahead and assume that. So let's go ahead and figure out the fraction the base is to the total. Alright? So what is the concentration of the base in this assumption? 1.8. Now, to figure out the fraction, we divide it by the total. So the concentration of the base is 1.8, and we're assuming the concentration of the acid is 1, so 2.8 is the total. And that will equal this thing, 64%. 0.64. So that means that 64% of this is the concentration of the base. So now that we have that, now we just take this and multiply by that, and then plug it in to this equation, and then solve for the concentration of the acid. So, concentration of the base is equal to 0.64 times 0.02, which equals, well, not 0.2, 0.02, it's 0.2, I should say. Alright, times 0.2. That's its concentration, 0.129. 9m. Then we do 0.2 minus that. We get 0.071. So the concentration of the acid is equal to 0.12, well no, 0.2 minus 0.129, which equals 0.071 m. So here's our answer. We have that the concentration of the base in the solution at this point, to give it a pH of 5, is 0.129. The concentration of the acid at this time is 0.071. So it's questions like these that, and also this question could be built upon, like there could be a certain volume and dilution and all that stuff. And this question could be built even worse, I should say. Anyway, try out these problems, and yes, yeah. I would recommend pausing the video at this time because in like, I want to know, 10 seconds I will reveal the answer. And at this point, assuming that you unpaused the video, the answers to these, number 1, what's the ratio of this? 8.98. I mean, this is pretty darn easy. You just like what we did here, we solve for the ratio, and that's basically the answer. It's just the ratio between these. I mean, this is the base, and this is the acid, so base over acid. Simple. Answer number 2 is 1.28 times 10 to the negative fifth. This question exactly the same as we did for the very first one, as you can see here. All that stuff. And then, how much of the unknown acid number 2 do you need to add in solution in moles to change the pH to 3? The answer to that was 2.74 moles. If you know what the pH is, or like you did everything exactly the same here, right? You just plug in 3 here and then solve for the base here and then subtract the difference, I should say. That's really all you have to do. Anyway, see you in the next video.